Hello, good afternoon. Can you hear me? Can you hear me, Akshay?
Yes, sir. I can hear you well. How are you doing? Good
Yeah,
afternoon.
good afternoon. Fine. How was your paper for?
It was decent, sir.
Okay. It's a little bit lengthy paper, na? 2 hours for 100 marks. It is lengthy paper, it is.
Yeah.
Okay. So this is the question paper we will be discussing today. Okay. Can you see
Yes,
the
sir.
screen?
Yep. Very well.
Yeah. So it is a 1 hour 15 minutes paper. Okay. For just 30 marks. So 2 questions are there. Okay. This is an 82 practical. Okay.
Mhm.
So first question for 15 marks, another question is again for 15 marks, like this.
Okay, sir.
The first question is something like this. A student is investigating how extension E of an elastic cord depends on the diameter D of the cord when a force is applied. Okay. The student has a number of elastic cords of the same material with different diameters. The elastic cords have circular cross sections. Each cord has an length of approximately 80 centimeters.
Mhm.
It is suggested that extension E and cross-sectional area A of the cord are related by expression E equal to F into L upon A into E, where E is the Young modulus of the material, F is the force applied, L is the unstretched length of the cord. Okay, so this is, I think, chapter number 7. Okay, that based on stress and strain. Okay, so ratio of stress upon strain. Okay, so that is kind of you will get the Young modulus. Okay,
Okay.
design a laboratory experiment to test the relationship between E and D. E is the extension and D is the diameter. Okay,
Mhm.
explain how your results could be used to determine the value for E, that is the Young modulus. Okay, so you don't have to conduct any experiment, just you have to tell, okay, how will you conduct, if at all, if you have to conduct this experiment. Okay,
Mhm.
so what all things that you have to write are these. You should draw some diagram on page 3. Show the arrangement of your equipment in your account. You should pay particular attention to. Okay, the procedure to be the followed.
Yes.
Next, the measurements to be the taken. Okay, what should be the control variables? Control variables means what is the independent variable. Okay, what is the dependent variable? What factors, what variables you have to keep it as a constant. Okay, and then how will you analyze the data, and then any safety precautions to be taken. Okay, any safety precautions to be taken. So this is it, and the space will be given to you, okay, for the diagram and for writing all these things. Okay, procedure, analysis of data, the variables, and the precautions. Okay, so in this question, see this last point, that is precautions. Okay, so like you have seen in the paper, uh, for the practical paper
Even-
3.
Okay. Yeah.
4
Yeah.
marks for the second practical, 4 marks for the was for the errors and 4 marks
Yeah.
for the improvement, 8 marks for that. Similarly, in the first question of this, 6 marks are just for writing the precautions. Okay, so you should write the
Okay.
six marks, all the 6 precautions. Okay, in points. Okay, in bullets you can write. Okay,
Got it.
okay. So this you should not forget. Okay, okay. So 6 marks are just for this. So at least 6 points you should write for this precaution. All right. Okay. So in the practical, have you done that first practical exam?
Yeah.
Okay. Okay. So that was a little
I
difficult.
missed the
Okay.
graph. That's all. Yeah, I could
My
like I
reading
could
was
do
also,
those.
reading was also not coming proper. Okay, my reading. Okay. So that's why I told all the students just to take some random readings. Okay, and plot the graph at least something to find out the gradient and something. Okay. And second
Okay.
practical, I think most of them you have done. Huh? So that was,
Yeah. Yeah.
okay, just 2-3 times you have to do that, and then you can do that. Huh? So,
Mm.
so tell me now, how will you do this experiment? Suppose you have to. What do you think? How will you do this? If this simple experiment is given, how will you do
Mhm.
it? What do you think? What variable you should keep? What is the independent variable? What is the dependent variable? And how the you will program? Okay. What variable you will keep as a constant? What do you think?
Um.
Read the question yourself and think. Okay, 5 minutes. Think.
Yep. Okay.
Okay. Just tell me verbally. Okay, you can write it down later also. I will share this question paper and marking scheme after the class. Okay. So
Okay. So,
you can write it later also if you want to practice. Similarly, do you have the more past papers for paper 5?
not yet, sir, but I can download it from the
Ah.
internet.
You can download some of the, okay, there's paper.sc, okay, there are websites and our paper.sc,
Um.
okay, paper.sc, okay, okay. So this is the website, okay, and the code is the 9702/52. Okay, this is the code for India. Okay,
I can't see the screen at the moment, sir.
chat you can see, chat.
Yeah. Got it.
Yeah. So think what you will write in this experiment if the experiment comes like this. What you will write?
Just take like 2 minutes, sir.
No, I won't.
Could you help me out, sir? I don't think I'm able to think right.
What do you think? Just tell me. What are you thinking? How will you do this experiment? Have to find out the relationship between the
Between E and D.
diameter and the extension. Okay. Yeah. How do you think we should proceed?
I'm blank at the moment, sir.
So see here, okay, how we will go about, okay. So here I have to see the effect of the diameter, okay. So area is connected with diameter as area is equal to pi d square by 4. Area is pi r square, or in terms of diameter it is pi d square by 4, okay. So I can just keep the material same, okay. So if I keep the material same, say if I take some steel wire, okay, or if I am taking some rubber or something, so same material I have to use, so that the elastic, so that the Young modulus remains the same, okay, because Young modulus, it depends on the type of material. So I will take the same material and I will take the same length, okay. I will take the same length of the string of the material, okay. But what I will do, I will vary the diameter. That means I will take different diameter of the, say if I'm taking a rubber, I will take different diameter rubber, okay, of the same length, say 50 centimeter or 10 centimeter, okay. So I will keep L also as constant, okay. And what I will do, I will keep the force also as constant, okay. So what I will do, I will hang some weight, I will hang some weight from the end of the rubber, okay. So what I will do, I will keep the mass also as constant, say 100-gram mass, so you have seen in the lab, okay, those 50-gram or 100-gram slotted weights I have shown you, that which we were hanging, so those slotted weights we can use, but we can keep the mass as constant, say 100 grams, okay.
Yeah.
If I keep the mass as constant, the force will be equal to what? The weight of the object, that is m into g, okay.
Yeah.
Weight will remain constant, that means the force will also remain constant, because we want to see the effect of the diameter on the extension, not on the effect of the weight varying force, okay. So we are keeping force also as constant, okay, length also as constant, the material also we are keeping it as a constant. So what all things we are varying? We are varying the diameter. So if diameter varies, the area of cross section will vary, and accordingly what will happen? The extension will be the different for the different diameter of the, say, rubber we are taking, okay. So how we will draw the diagram? So diagram will kind of now can you draw the diagram? Okay, so diagram, rough diagram I am drawing, okay. So you can think of it, you have some diagram you have to draw.
So we can use the vernier caliper to like measure the diameter, is it?
Yeah, that will also be used, huh?
Yeah. So we'll be counting the apparatus as well, right, sir?
So you have to draw the diagram like this, okay. So we will take some stand, and like in the lab you have seen some stand is there, okay.
Yeah.
So some stand we have to take first, okay. So this is the stand, okay, and this is the boss and the clamp, and we will use some boss and some clamp we will use, okay. Some boss and some clamp we will use, okay. So with the clamp we will hang the material which we have to test, okay. So we will hang that material, suppose this rubber, okay, rubber wire or something like that, okay. And we will be hanging the weights, different weights we will be hanging, okay. We will be hanging different weights, okay. So like we have seen the weights, so we were hanging the weights, and like this we were hanging some weights, okay. Some weights we will hang, say 100 grams or something, okay. So we will hang these weights, and what will happen with the, first of all we will not hang the weight, and using some scale, using some ruler, okay.
Yeah.
That
We can
ruler,
measure the unstretched length,
we can
and then we can measure the stretched length.
Yeah. So we can also fix using some ruler, okay. So we will show some ruler also, and we can show another stand also, so we will fix the ruler so that the ruler doesn't change, so we can show another stand also here, okay. And we will take this reading and this reading,
Yeah.
and by this we can find out the first of all unstretched length, and then after hanging what is the length, and we will subtract
After
it.
it's stretched.
Subtract it. Okay, so we can find out the extension. So we can find out the extension E, and that is the extended length minus the
Yeah.
unextended length. Okay.
Unstretched.
L
Yeah.
minus L naught. And also we are taking the wires of different diameters. Okay. Different diameter wires we are taking. Like we are taking wire of, say, like this, and we are taking, then we will increase the diameter. Okay. Then we will take a wire of another diameter. Okay. Take another wire. Okay. Of another diameter we will take. Okay. Like this we will take, but the same length we will take. Okay. Same length we will take. Okay. But different diameter and increasing diameter we will take. Okay. So we require some instrument, that is a vernier caliper. Okay. So we will use a vernier caliper also. Okay. So we will use a vernier caliper also to measure the diameter. So we will use a vernier caliper. Okay. Vernier caliper.
And for the weight, we can use the weight balance, right? And multiply it by G.
You can use what it is, or usually written. Say you are using 100 gram.
Okay.
So 100 gram divided by 1000, you will get in kg, 0.1 kg multiplied by 9.81. So you will get the force in the newtons. Okay. So I think we don't have to measure it. We know the formula for that. Okay. So we need some vernier caliper. Okay, to measure the diameter. Okay. So we will use some vernier caliper. Okay. Some vernier caliper also we can draw in, or you can just write it down. Okay, that we are using some vernier caliper. Okay. Vernier caliper is like this. Okay. So in between we'll put that wire. Okay. And this is some kind of a vernier caliper. Okay. Okay. So this is some kind of a rough diagram that you will have to draw. Okay. The rough diagram. Okay. And then, okay. See the marking scheme. This is the marking scheme. Oh. This is the marking scheme. Okay. So how the marks are distributed, see here. Okay. So here, can you see the screen?
Got it, sir. Yeah.
So you see here, D is the independent variable. Okay. D is the independent variable which we are varying. Okay. And then based on the value of D, we are getting value of E, that is the extension. So here E is the dependent variable. So we have to clearly write what is the dependent variable, what is the independent variable. Okay. And here also what we are doing, we are keeping the force as constant. You can write the length of the constant. Okay. So here this is the constant variable that we are keeping it as a constant. Okay. And see what you have to show. You have to label the workable diagram. You have to show.
And so we have to explain it also, right? That we have to take multiple readings and measure the new length after it's extended and subtract it from the like unextended length and all of that.
Yeah, that will come under procedure. Okay.
Okay.
So workable diagram, there is 1 marks for that. Okay. So see how the marking they are giving. Okay. For writing independent variable and dependent variable, there is 1 mark. For writing the control variable, that means what we are keeping as a constant, there is 1 marks. Okay. For the diagram, there is 1 mark. Okay. And then you are explaining it. Okay. That means in the diagram, if you have shown a ruler, okay, unstretched length and stretched length, okay, and you have drawn a ruler that is parallel to the wire, okay. So there is for that there is 1 marks, and then we are using a micrometer or some vernier caliper to measure the D. So there is 1 marks for that. Okay. And then weight, we are using the weight, and we are multiplying with G to find out the force. So there is 1 marks for that. Okay. So all these things, some diagram you have to show, and some in points you can write down the procedure. Okay, and the variables. Okay. Now you have to analyze the data also. So what you will do, you will plot. Okay. You will plot 1 upon D square versus E. Okay. So you will plot E versus 1 upon D square. Okay. So this will be some kind of you can say a straight line you will find out, and then using that straight line you can find out the gradient of that line. Okay.
Okay, so
Like you are doing it for different diameters, and so you will get different points. You connect those points, okay. So you
Mhm.
find out the gradient of the best fit line, okay, and then you can
Okay.
using the graph, okay, you can find the value of E. Because if you read that question, they are telling that determine how your results could be used to determine the value of E. Okay,
Mhm.
so you have to use this. Okay, that gradient you have to use this. Okay, so using that gradient you can find out the value of E here. Okay,
Yeah.
like E here is what? F into L upon A into E. Okay,
So
E is equal to, I can write it down. E is equal to
4FL upon pi into
F into
gradient.
L upon A into E. Okay,
Mhm.
so this I can write it as, I can force into length upon area, I can write pi d square by 4.
Yeah.
So 4 will go in the numerator and E. Okay, so what we are plotting of is, we are plotting
E against 1 by d square.
E against 1 by d square. Okay, so this will be kind of a, so E is equal to, so we can take this, we can make E as the subject here, and so we can take E on the
Mhm.
left hand side. Okay, and this capital E, that is elastic, that is Young modulus, will come here. Okay, so we are taking 1 by d square as the variable. Okay, so and what all things are coming here, other things will be the constant, so that is 4f, okay, upon pi into E.
Pi.
And this is the constant, so you can compare it with the equation of a straight line, y equal to mx plus c. So here no,
Yeah.
c is 0 because it is passing through the origin. Okay,
Mhm.
c is 0, so you can compare it, so you can get the gradient here. That gradient will be, okay, so you can this y is nothing but the E. Okay,
Mhm.
this 1 by d square, we are taking it as x, and this 4f upon pi E, this is nothing but the slope or the gradient.
Yeah.
So here m is equal to 4f upon pi E. Okay, so
Got
how
it,
we
sir.
can find out E? E we can find out, E will be equal to 4f upon
L.
pi into m. M is nothing but the gradient. Okay,
Yeah.
that's what they are showing here in the marking scheme. And 4f upon pi
Got it.
into 4f upon, no, pi into the gradient. Okay, so, okay, something
Mhm.
we are missing, I think length, and length we have not shown. Yeah, length is also there.
Yeah.
Length is also here. Okay, so this
Mhm.
length will also come here. Okay, this length is also here. Okay,
Mm.
so that's what they have explained in the marking scheme. Okay,
Got it.
and then, so that was the how we'll find out the E, and then the 6 points you have to write down. So what all the precautions you can take. Okay, so you can see some precautions, 9 precautions they have given, so you can write down any 6. Okay, like you can something, okay, like
Mhm.
you can
Safety goggles, safety screen, cushion, and sandbox.
we are keeping L as the constant. Okay, and
Method to
method to
keep L
keep L as
constant.
constant, to kind of, like you can keep, you can check the length of the cord every time you take and hang the weight. Okay,
Got
okay,
it.
then what else you can do? So you should measure the initial length and the final length properly. Okay, and
Mhm.
like you can repeat the D. Okay, like you can take D for different, take
Mhm.
3 different readings and take the average. Okay, and take the average.
Mhm.
Okay, next you can see if the Hooke's law is obeyed. Okay, because if we hang very large mass, then what will happen? That the wire will not come back to the original position. Okay, so as you know the Hooke's law, still certain position. Okay, it follows the Hooke's law. That means it's a straight line. A stress versus a strain curve, it's a straight line. After that point, what happens? It curves, and it will no more be a straight line. So you can check this Hooke's law whether it is obeyed or not. Okay, so when you remove that way, the wire should come back to the original length. So you can check that. Okay, and then you can wait for the wire to extend. Okay, okay, or stop oscillating. Okay, so when you hang the weight, it will kind of oscillate little bit. So you don't take the reading at that point of time. You wait for some time and take the reading when it comes to the rest. Okay. And for area you are using pi d square by 4. Okay, and then we can use a set squares to check, and like we have shown in the experiment, to check if the stand is vertical or not. Okay, also you can write, and we can like in the graph here we have not fixed the scale, so we can take another stand and we can fix the scale. Okay, okay, we can fix the scale using another stand. Okay, so all these points you will be writing down, okay, in the precautions, and that carries 6 marks. Okay, so don't forget to write it down, and I will suggest that you write it down.
Writing down right now, sir.
The points. Okay, okay, so write down clearly the independent variable, the dependent variable, the independent variable, or the controlled variable. Okay, in points, the procedure, then you write in the points what procedure you are writing down. Then analysis, method of analysis, so you write down, you are plotting a graph, you are finding out the relation, you are finding out the gradient. In the gradient you are finding out the unknown. Okay, and then precautions. In precaution write down 1 2 3 4 5 6. Okay, so like that if you do, you will get 15 marks for that. Okay, first experiment. All right.
Got it, sir.
Also in the book, okay, if you take the PDF of the book, I have given it to you, and if you have the hard copy, that is very good.
Got it, sir.
Okay, so we have close to the end of the chapter. Okay, close to the end of the book. Okay, we have these things related. Okay, things related to this paper 5 are given to you. Okay, how to plot the graph. Okay, and about the errors and all. Okay, all these things are there. Okay, especially these errors and treatment of errors, how we find out the errors. Okay, different types of errors. So what I will suggest, you read this. You have 2-3 days remaining.
Yes, sir.
Is on 19th. Okay, so you read this as actually something on the uncertainties. Okay, that will be helpful. Okay, that will be helpful. So now the question number 2 we will discuss. Question number 2 we will discuss.
Got it, sir.
When is your next exam?
That's on 18th, sir.
18th. Okay. So I think 19th you have 2 papers now, I think, for physics.
I have 3, sir.
3 papers.
Yeah.
Okay. So see, this is the second question. Okay. So read the question. The student is in investigation monochromatic light passing through a double slit. Okay. So this is the Young's double slit experiment. So you can see, or you can observe the constructive and destructive interference. So wherever you find out constructive interference, there are bright patterns, and there are in between there are dark spots, that is destructive interference. So this is called as fringes. So if I place a screen somewhere ahead of the double slit, we will observe this kind of a pattern. Okay, alternate dark and bright spots of equal length. Okay. So here in this experiment, they are measuring W. W is the width. Okay. So this width or the distance between 10 bright fringes. Okay. They are measuring. Okay. That is the width of the 10 bright fringes. So what we can use, we can measure this 10 bright fringes and we can divide it by 10. So what we will get the width of one fringe. Okay, that means width from one bright spot to another bright spot we will get. Okay, one bright spot to another bright spot. Okay. So this meeting will end in 10 minutes. So I will again renew this meeting. Okay. So you be there. Okay. Yeah. So
I couldn't hear the last like 10-20 seconds.
so this meeting will end in 10 minutes. Okay. So I will again renew. Okay.
Okay.
So be there in that. So W divided by 10, what I will get? I will get the fringe width, fringe spacing we call. So here the fringe spacing, they are calling it as P. Okay.
So P is W by 10.
W by 10. Now also some relation is given to you between the fringe width P, okay, and the wavelength. Okay, so there is a relation that is given to you, that is P by D is equal to lambda by S. P is the fringe spacing, D is the screen, length or distance of the screen, okay, from the slit. Lambda is the wavelength of the light that we are using, and S is the distance between the slits. Okay. So the Young's double slit experiment, famous experiment is there. Okay, you can read it in the book also. Okay, and that is in the AS syllabus. Okay, in the chapter on waves. Okay, this is there in your AS syllabus. Okay, on the waves chapter. Okay, so this relation is there given. P by D is equal to lambda by S. Okay. Now, so this is a very simple question. Okay. So what you have to do here, a graph is plotted on the y-axis, P is plotted on the y-axis and lambda on the x-axis. Determine an expression for the gradient. Okay. So what do you think? What will be the gradient? Look at the formula.
So y equals to n plus c I into d by 5 d by 5 d by s, yeah, d by s.
So the gradient will be d by s. Okay. So you write down d by s. So that will give you the gradient. And for that you have 1 marks for that. Okay. Sometimes what happens, we have to take the log also, and log both sides, and then you have to find out the gradient and the intercept. Okay. Sometimes you have to do like that. Like you can see here. And like you can have a relation like y equal to ax and to the x to the power n. Okay. So, so in that case, how will you find out the graph? So you can take the log both sides. Okay.
Okay.
So suppose it is y equal to ax to the power n. So what you can do, you can take natural log both sides. So it will be ln y equal to, you know the log, how to find out the log?
Yeah.
So it will be ln a, I'm writing it down directly, plus n ln x. Okay. So here, now this is the variable. Okay. So this you can compare this, you can take it as a y equal to mx plus c. Okay. Here ln x, you can take it as x. So there n will be now the variable, it will be m. And this ln a, this will be
that will be pi, right?
This will be
for
the
this equation.
Intercept. Okay.
Yeah.
So like this also you can have to do. Okay, in some of the question. Okay, but this question is simple, so you don't have to go into that. Next, what will be given to you? Some table will be given to you like this. Okay. Like here lambda is given, different values of lambda and different values of width are given to you. You have to find out the value of P. Okay.
That would be W by 10, right?
That will be W by 10. So you just divide it by 10.
So now, I just have to like shift. Okay.
Decimal just one place left, it will shift, and also at the uncertainty you have to find out. Okay, so like here uncertainty, it is very simple. Okay, that will also get divided by 10. So you have to write it down like this. See the marking scheme. Okay. So 3.95, 4.35. Okay. So like that you have to draw the table. Okay, and then The uncertainty also you have to write down, absolute uncertainty. So that will be the P plus minus 0.05 it will become. Okay.
All right.
Okay. So like this. So for that you have 2 marks for that. Okay. And then
Understood.
plot a graph of P and against lambda and include the error bars. Okay. So you have to plot the graph. Paper will be given to you in the question itself. Okay. You can see here P versus lambda. So the different 6 different points. You'll have to plot it. Okay. And then in that you have to plot the error bars. Error bars means like here, like you are plotting what? Say first point you are plotting how much? 3.95.
3.95.
Okay. So you plot 3.95, 4.35, 4.80 like that, 6 different points. And then you have to draw the error bars like this. So see here, error bars are something like this. Okay. Error bars are like this. So these are the points, different points. Like, so suppose this is the point. So I am adding, I am plus minus 0.05. So first of all, I will add plus 0.05 and whatever value I get, I will put a bar like this. And then I will subtract.
It's like about 2.5 square, I think.
Okay, yeah. So it will be like, for this case, it will be 3.95 plus 0.05 and 3.95 minus 0.05. Okay. So like that you will plot like this. Okay. So these are the error bars. Are you getting it?
Yeah.
Okay. So these are the error bars you have to draw. So for that also you have 1 marks for that. Okay. And then you will draw the best fit line. That means you will choose a line that passes through the maximum number of points. That will be the best fit line. Okay. That will be the best fit line. And then you have to find out the gradient also. And a gradient of the best fit line. So what you will do, you will choose some point. Okay, some point say here.
Yeah.
So take some far away point, some point like here, some point like here. Okay, and then you show the some triangle like this. Okay. You show some triangle like this. Okay. You show some triangle like this. Okay, like one point you are taking here. Okay. You show some triangle like this. Okay, like one point you are taking here. Okay. Okay. Another point you are taking here. Okay. You find out the coordinates x1, x2, and y1, y2, and then x2, y2 minus y1 upon x2 minus x1, and that will give you the slope of this. Okay. So you draw like this. Okay. So show like this. This is the gradient that you are finding out, tan theta. Okay. This is 90 degrees. So show it like this on the graph. Okay. Okay. So all these things you have to do. You read the question, they have written it here. Draw the straight line of best fit and determine the gradient of the best fit. Okay. And then see here, worst acceptable line also you have to draw here. So how will you find out the worst acceptable line? So worst acceptable line is here like this. Okay. So you take the bottom most of the first point, this last point. Okay. And join it with the topmost of this first point. Okay.
Okay.
Hitting this
topmost of the first error point and the last most of the last error point.
This error bar like this. Okay. So this is the worst acceptable line. Okay. Worst acceptable line. Okay. This point and this point you join. Okay. And then again for this point you have to again make a triangle and find out the gradient of this. Okay. Find out the gradient of this. So because in the you have to find out the uncertainty also. You read the question here. You have to find out the uncertainty in your answer in the gradient. So uncertainty in the answer, and if you see the marking scheme. Okay. So see here the uncertainty in the answer, that will be the uncertainty is equal to gradient of best fit minus gradient of worst fit. Okay. So that is the uncertainty. Okay. So you have to find out the slope of the worst fit line also. Okay. Slope of the worst fit line also. So like this, if you do, you will get these marks. Okay. So see here.